Welcome back. In this video, we learn about moving average, weighted moving average, and exponential smoothing forecasting. So here I have a data set of product B from January 2020 to February 2021, and I need to forecast it for March 2021. So here I have a gross sales and I need to forecast the sales in three different methods for the gross sales for March 21. And for the moving average, let's say we want to forecast for like 4 periods. You can do it for 3 periods as well and 2 periods as well, whichever you need. In this video we'll forecast with 4 periods. So since we want to forecast it by 4 periods, so we'll make an average of the 4 most recent 4 and then click enter. This way we'll get an average and we'll click this button and drag it down. So this will give us a moving average of 4 periods up to March 2021. Let's fill up this cell with yellow. And now for the weighted moving average, the weighted moving average is a little bit tricky. You need to weight your previous values. Here I have a table with the weights and I have a requirement of weighting the fourth most recent period with 0.1, third most recent period 0.2, second 0.3, and the most recent period with 0.4. So you may have this kind of weights and whichever you want. You can have a 3 or 4 or 5 or 2. Here we'll be doing with the 4 periods, 4 weights. So let's begin. You need to give a formula. This is a little bit complicated, but not so much once you understand it. So we need to give the fourth most recent period. Our fourth most recent period is the first one, and we need to weight it by the weight value, which is n2, and we have to give it an absolute reference by pressing F4 from the keyboard. This will lock this cell when we drag it down. Now for the third most recent value, we need to multiply it with the third most recent weight, absolute reference again. Similarly perform the third most recent period, multiply it with its corresponding weight, absolute reference it. Similarly for the fourth most recent period, the most recent period, multiply it with the weight and absolute reference it and press enter. And now we'll drag it down. When we drag it down, the weights will be fixed since we have given absolute references to it. We'll give the predicted cell, forecasted cell, yellow formatting again. Now for the exponential smoothing, for this forecasting method, we'll leverage the data analysis tool pack for this thing. So let's go to the data tab and go to the data analysis section. Here we will see the exponential smoothing, which I have already selected. Click OK, and from here input range, input the gross sales, the data which is already available to you. And now for the dumping factor, and this is a little bit tricky, you need to understand it. You will have a dumping factor, and this weights it works like a weight and weights your recent values you will see in the formulas. It will be more understandable. For now, we'll give it 0.1. If you have a damping factor already in your requirements, give an input here. For our output range, this will be this format, since we have our data from N9 to N22. That is why we need to select the output range to Q9 to Q22. It should be same, the output range and the input range, and press OK. Don't select labels if you don't have labels in the input and the output range. When you click OK, we'll have a error in the first cell, and this is natural. And here we can see in the second cell we have the same value as the first gross cell. It works like it references the first data into the second cell, and then it weights the values. Let's see the second value. You can see here, here is a formula here, and this is saying that it has weighted the most recent value with 0.9. Recall that we have given a damping factor of 0.1, which works like a percentage, which is 10%, and from the most recent value it has deducted 10%, which means it is now weighted like 90%. That's why it has given 0.9, and it has given the previous value a weight of 0.1, which is the same as the damping factor. So this is how all the values are calculated from cell Q10 to cell Q22, and but we don't have the forecasted value for the March 2021. So in order to do it, we already know the formula. What we need to do, we need to give the weight. Since we have a damping factor of 0.1, but for the recent value it will be 0.9, because it has to be 1 minus the damping factor. So it is 0.9 multiplied by the most recent value, and plus damping factor 0.1 multiplied by the previous value, which is this value, and press enter. This will give the March 2021 exponential smoothing forecasting. Now we'll edit this cells. We'll give a currency here, and we need a dollar sign, so we'll give a dollar sign from here, and we'll just format the cell giving some borders. So this is how we can do forecasting, moving average forecasting, weighted moving average forecasting, and exponential smoothing forecasting. So it is quite easy, and I hope you find it useful. So in the next part, we will see how to calculate the absolute mean absolute deviation, mean square error, and mean absolute percentage error. So similarly, we have calculated our weighted moving average. You can see we have the weights here, and we have the actual values here and the forecast here. Similarly, we have done a 4-period moving average, and we need to calculate the MAT, MAC, and MAPE for this weighted moving average. You can do the same for the exponential smoothing or moving average only. So in order to calculate we need to first calculate the errors. So we'll give the value by first value of forecast minus the actual value This will give us a value, and we need to drag it down. The brackets are telling us that this value is a negative value, and you can have just a negative or have a formatter like this, like the negative one. Now for the absolute value, we need to calculate the absolute. So there is a formula for it, ABS, which means absolute, and we need to click this cell and it will make an absolute value of it. You can see it is giving the absolute value, and there is no signs or brackets here. And in this cell we need to square the errors, this cell, square it and drag it down. And in this cell we need to calculate the percentage. So in order to calculate the percentage, we need to divide it by the actual value. So we'll divide the absolute error by the actual value, and this will give us a percentage, and we'll drag it down. After having the values, we need to calculate the totals of these values, sum from the formulas, and we need to sum up our forecasted values and drag all the way to column Z. So this will calculate all the sums of these values, and now for which we need to calculate the MAD, MAC and MAPE, for which we need to divide it by the number of forecasts we have made. We have made a forecasts like 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in total, not 9, it's 8 actually, from here to here. So it is 8. So we need to do, we need to divide the total value by the forecasting count. We can do that by formula. There is a formula for it. Click rows, type rows, and then select any forecasted values or the errors from E13 to E20. Will give, and this will return the count of the number of forecasts, since it is similar as our forecast. So it will be okay, and click enter. So we can see that our MAD, mean absolute deviation, is 2.84. If we drag it down, drag to the column Z, we will have the other values as well. We can see that our mean absolute deviation is 2.84, our mean square error is 10.44, and our mean absolute percentage error is 2%. Let's make it a percentage. So this is how we can calculate the MAD, MAC and MAPE. For the interpretation, the lower these values, the more accurate your forecasting is. So this is how you can compare your values as well. So I hope you liked this video. You have learned how to forecast your data, and how to interpret it also by calculating mean absolute deviation, mean square error and mean absolute percentage error as well. Thank you for watching. Hopefully we'll be meeting in the next useful video. Thank you.